We want to take a look at a more general form of finding our slope of our tangent. So if we take a look at our picture here, we now have the distance in between our x and our a being this distance h here. So as that distance is decreasing, as my point Q is moving closer and closer to my point P, and we're getting closer and closer from our secant line becoming a tangent line, then we can write our limit, our slope of our tangent, as the limit as h approaches 0 of f of a plus h minus f of a all over h. So it just gives us a different way to find the limit. Let's try that with our same problem that we did on the front side, y equals x squared. Let's use this second definition and see if we can get the same slope. So I'm going to find the limit as h approaches 0 of f of my a is my x coordinate. So I'm going to have f of 1 plus h minus f of 1 all over h. So now I'm going to go ahead and plug 1 plus h in for my x and 1 in for my x. So if I plug a 1 plus h in to my x squared, that's going to be a 1 plus h squared minus. If I plug 1 into that x, that's going to be a 1 squared all over h. So then we can go ahead and multiply our binomial out, multiply itself times itself. A 1 plus h times 1 plus h is going to give me a 1 plus 2h plus h squared minus 1 squared is 1 all over h. Notice that your 1's cancel, and you can factor out that h. So I've got the limit as h approaches 0 of h times 2 plus h over h. And we can cancel out the h in the numerator and the denominator. So now when I plug a 0 in, 2 plus 0 is 2. So we get the same slope by using a formula that's a little bit more of a general formula. Let's do the same thing for question 3. Let's take a look at finding the slope of the tangent when x approaches a and when h approaches 0. So if I start off with my first definition here, we want to find the limit as x approaches 8, because that's my x coordinate. So I'm going to find my slope is going to be equal to the limit as x approaches 8 of f of x, so the square root of x plus 1, minus f of a, the square root of 8 plus 1, all over x minus a, so x minus 8. We can simplify our numerator as the square root of x plus 1 minus the square root of 9 is 3, all over x minus 8. We know that anytime we have a radical, a square root, in our limits, we have to multiply top and bottom by the conjugate. So let's multiply top and bottom by a square root of x plus 1 plus 3 and a square root of x plus 1 plus 3. In the numerator, our firsts are going to give us an x plus 1. We know that our outer terms and inner terms are going to cancel. And our last give us a negative 9. All over, always leave the other pair in factored form, x minus 8 times the square root of x plus 1 plus 3. Well, now I look and I have the same factor in the numerator and the denominator. I have an x minus 8 and x minus 8. Those are going to cancel. And if I plug that 8 in, I've got the limit as x approaches 8 of 1 over the square root of 8 plus 1 plus 3. And that's going to give me 1 over 3 plus 3 is 6. So that gives me a limit of 1/6. So that means that the slope of the tangent, or the slope of the curve, at the point 8,3 is 1/6. Now let's try doing the same thing with our other formula, our equation 2. So for part B here, we want to find the limit as h approaches 0 of, let's look at our equation, f of a plus h minus f of a all over h. Our a is always our x-coordinate. That's going to be our 8. So we're going to take f of 8 plus h minus f of 8 all over h. If I plug an 8 plus h in for my x, I'm going to have the square root of 8 plus h plus 1 minus, I'm now going to plug an 8 in for my x, the square root of 8 plus 1 all over h. So let's go ahead and simplify that down a little bit. I'm going to have the square root of 9 plus h minus the square root of 9 is 3 all over h. So this time, just like we did in the first one, we got to multiply top and bottom by that conjugate pair. So we've got the limit as h approaches 0 of the square root of 9 plus h minus 3 all over h. We want to multiply top and bottom by the square root of 9 plus h plus 3. Square root of 9 plus h plus 3. So when we do that, my firsts are going to give me a 9 plus h. My outers and inners are going to cancel. My lasts give me a negative 9 all over h times the square root of 9 plus h plus 3. So in the numerator, those 9's cancel. I'm left with h over h times my quantities, so the h's cancel. And if I have 1 over the square root of 9 plus h plus 3, and I plug a 0 in for my h, I'm going to have 1 over the square root of 9 is 3, so 3 plus 3 is 1/6. So we get the same exact using either formula. So now for question 4, choose whichever formula you want. You can either have x approach 3, or you can have h approach 0. It just depends on which one you're more comfortable with, since they didn't tell me which one to use. So let's go ahead and, for question number 4 here, find an equation of the tangent line to the hyperbola y equals 3 over x at the point 3, 1. Let's go ahead and use our first formula, because I think we might be a little bit more comfortable with that. If I find the slope of my tangent at the point 3, 1, I want to find the limit as x approaches 3 of f of x minus f of 3 all over x minus 3. So if I take my f of x, that's going to be 3 over x minus, plug 3 in for your x, 3 over 3 is 1, all over x minus 3. In the numerator, we need to create one fraction, so I'm going to multiply top and bottom by x over x, and that's going to give me 3 minus x over x all over x minus 3 over 1. I know that when I'm dividing fractions, that my first fraction stays the same, 3 minus x over x. We change our division to multiplication and flip over our bottom fraction. Well, when I do that, notice that my numerator has 3 minus x and my denominator has x minus 3. So let's factor out a negative 1 out of our numerator, and that's going to give me a negative 3 plus x over x times x minus 3. So I can see that my x minus 3's are going to cancel, and remember that we were finding the limit as x approaches 3, so I can now plug a 3 in for the x, and I get a slope of negative 1/3. Once I find my slope, and I have a point, I can write the equation of my tangent line in point-slope form. So y minus my y-coordinate, y minus 1 equals my slope, negative 1/3, times x minus my x-coordinate, x minus 3.